Okay, I hope you still remember that lump sum is just a single payment. Ordinary annuity is a series of equal payments at the end of each period. Annuity due is a series of equal payments in the beginning of each period. Okay, and all other cash flows are uneven cash flows. They can be of different amounts at different times. Okay, and then we learned that we can calculate future value and present value of lump sum by using either the formula listed here or by using the TVM worksheet on our financial calculator using the NIPV, payment, FV, these 5 buttons. Okay, present value and future value here should have opposite signs. Interest rate here should just be input the number without the percentage sign. Okay, in today's class, we're gonna continue to work on future value and present value for annuities or uneven cash flows. So we're gonna do present value or future value of other types of cash flows except for besides lump sum. So again, we're gonna calculate future value and present value of ordinary annuity, okay, which occurs at the end of each period, and annuity due, which occurs in the beginning of each period. We're also gonna introduce a very special annuity called perpetuity, and we're gonna calculate the present value of perpetuity using formula. For uneven cash flow, we're gonna also learn how to calculate its present value by discount all the cash flows to present. Okay, so for ordinary annuity, annuity due, and uneven cash flow, we're gonna learn how to calculate present value or future value using formula or using calculator. But we're in practice, we will rely a lot on the financial calculator. For perpetuity, we're gonna just use the formula, and a scientific calculator would be enough. Okay, so let's review what is ordinary annuity. It could also be called deferred annuity. It is a series of equal payments that occur at the end of fixed intervals for a specified number of periods. Okay, we can see in this graph here, it's a sample of ordinary annuity. We have 3 payments at the end of each period. Okay, what if we have a 3-year ordinary annuity of $100 at 10% interest rate? What is the future value of this annuity? So we can use the timeline we learned last class in the last video to draw this the information here. So we can draw 3 periods from 0 to time 1 to 3. We have 3 years here shown in this timeline. And because we have 3-year ordinary annuity, we can mark 3 100s. Okay, it could be positive or negative depending on how you want to define these 3 100s. If it's positive, it means cash inflow. If it's negative, it means cash outflow. Okay, either is fine because this question doesn't specify whether it's income or expense here. Okay, and we also mark 10% interest rate above the first period on the timeline. Now we can calculate the present value of the 3 100s. Okay, we can just use the, first let's look at the future value. Okay, let's look at the future value of these 3 100s. We can just use the formula future value of ordinary annuity, which is payment multiplied by 1 plus interest rate to the power of n minus 1 divided by interest rate. Okay, so for this formula, if you're interested in how we derive it, you can contact me through email or set an appointment with me. I can show you the derivation of how we get this formula. Okay, basically, we treat the payments of the annuity as a geometric series. and we use the summation formula of geometric series. Okay, and because the and that can be simplified into this format here. Okay, this is how we derive the future value formula for ordinary annuity. You are not required to know the derivation. However, you should know how we can use this formula. Okay, in exams, you're gonna be provided these formulas, so you don't have to memorize them either. But you need to know that what each variables here stand for and what numbers you should use to when you are using the formula. Okay, for example, here the payments would be 100 because we have 3 100s. And then also in the formula I, interest rate would be 10%, okay, because we're using the formula, so we keep the percentage sign. N is number of years, so we use 3, okay, and then we plug the numbers into the formula. The future value of this 3-year ordinary annuity would be 100 multiplied by 1 plus 10% cube minus 1 divided by 10%. So we have 331 as our future value. Okay, this is how you can use this formula to solve for the future value of 3-year ordinary annuity of 100 at 10% interest rate. Okay. Again, in the exams, you would be provided a formula sheet, so you just need to find the right formula to use and then put in the right numbers. A second way of solving this question is to use our TVM worksheet. Okay, let me show the financial calculator here again. Okay, I hope you already changed your decimal to 4 by pressing second format, 4, enter, second quit. Okay, so you see 4 decimals here. And because we have 3 years, so we input 3 as N. And then we input interest rate as 10, I. And then for present value, we do not have present value because there's no cash flow at time 0, okay, 0 PV. For this payment here, it's by default. It by default means ordinary annuity. Okay, this payment means ordinary annuity, and we know it's 100 payment. Okay, because we have N as 3, payment as 100, so the calculator knows we have a 3-year ordinary annuity. And then we compute for FV, future value. Okay, we see negative 331. Okay, so it means if you have a ordinary annuity for 3 years of 100, okay, and if it's positive number, meaning you're getting $100 at the end of each year, then after 3 years, you have to pay back 331. Okay, alternatively, you can also input payment as 100 negative payment, which means you're depositing or paying $100 at the end of each year for 3 years. And then if you compute for future value, you're going to see a positive number, meaning you're going to get or withdraw 331 after 3 years. Okay, so here, payment and future value seem to have opposite signs. Okay, again, no free lunch rule. All right, this is how we can use the financial calculator to calculate the future value of this 3-year ordinary annuity. Okay, you can also see the procedure here on our notes. Okay, let's look at a second question. What if it's the same ordinary annuity, but this time we want its present value? Okay, it's gonna be a different formula. Present value of ordinary annuity, PVA ordinary, equals payment multiplied by 1 minus 1 over 1 plus interest rate to the power of n divided by interest rate. It is also future value of ordinary annuity divided by 1 plus interest rate to the power of n. Okay, because any present value is future value divided by 1 plus interest rate to the power of n. Remember, this is the present value of a lump sum formula. Okay, so in this question, we have payments equals 100, interest rate equals 10%, n equals 3. So we just plug the numbers into this big formula here. Okay, we have 100 multiplied by 1 minus 1 over 1 plus 10% to the power of 3 divided by 10%. So we have 3, or we can use the 331, the future value of this annuity we just calculated, divided by 1 plus 10% cube. Okay, either formula works. Either of them will bring you the number of 248.69 as the present value. Okay, a second method would be using our financial calculator. Okay, we still have 3 as n, 10 as I, 100 as our payments, but this time future value is 0. Okay, I know we have 100 at the end of the third year, but that's already incorporated by using payments. So we don't have additional lump sum at the end of the third year anymore. So future value here is 0. Okay, future value is anything additional besides the annuity at the end of all the years. Okay, now we compute for PV. We see negative 248.6852, which is around negative 248.69. Okay, this is the present value of this ordinary annuity. If you change 100 to negative as our payment and compute for PV, you will get a positive number instead. Okay, so here PV and payment, they are opposite signs. No free lunch rule. Okay, so that's how we calculate future value and present value for ordinary annuity. The second type of cash flow we want to work for is annuity due, which is a sister annuity or very similar to ordinary annuity, but it occurs at the beginning of each term. So if we move the 3 payments of ordinary annuity 1 period ahead, okay, from term 1 to 3 to term 0, 1, 2, we can have annuity due. Okay, so what if we want to know the future value of a 3-year annuity due of 100 at 10%? We can either use payment multiplied by 1 plus interest rate multiplied by 1 plus interest rate to the power of n minus 1 divided by interest rate, or we can use the future value of ordinary annuity multiplied by 1 plus interest rate. Why? Because if we look at this annuity due here, and if we add a timeline that's negative 1 to 0, and if we look from negative 1 to 2, this annuity due becomes an ordinary annuity. Okay. If we add 1 period ahead, all these 3 payments which occur in the beginning of each period becomes at the end of each period for the first 3 periods. So if we calculate future value of ordinary annuity, it's going to be occurring at term 2. If we want to move it to term 3, so it's the future value of this annuity due, we just multiply by 1 plus interest rate. Okay. So here payment is 100, interest rate is 10%, n is 3. So we can use 100 multiplied by 1 plus 10%, multiplied by 1 plus 10%, cube minus 1 divided by 10%. So we have 364.1. Okay, alternatively, we can use the future value of ordinary annuity, which is 331 from the last example. we calculate it and use this number multiplied by 1 plus interest rate 10%. So we still have 364.1. If we want to use financial calculator, here we're working with annuity due instead of ordinary annuity. And we know that this payment button here refers to ordinary annuity. Okay, by default, the payments occur at the end of each period. So now we want to change. Okay, let me press second quit. Let me press second begin. Okay, you see the BGN, the begin button is the same as payment. So we press second begin. You can see that by default, it is in end mode. Okay, I want to change it to begin mode. And the instruction on the screen tells you that we can use set sign to change the setting. And it's the same button as enter. So I press second, set. Okay, you can see the screen changed into BGN, begin. Okay, let me just press second quit. Now you see there's BGN on our screen, meaning any payment you input now will become annuity due, which occurs in the beginning of each period. Okay. For this question, we still have 3 as N, 10 as I, okay, 0 as present value, 100 as payments, compute for FV. Now you see 364.1. Okay, the payment you input here is 100, but it's in begin mode, so it's $100 at the beginning of 3 years is worth 364.1 after 3 years. Okay, if you want to switch back to end mode, change the payment back to ordinary annuity from annuity due, you need to press second begin, second set, okay, until you see end, and press second quit. So now nothing is on the screen anymore. It means the payment goes back to ordinary annuity. Okay, let's look at another example here about the present value of this same annuity due. Okay, the formula is a little bit similar, but a little different. So we can use payment 100 multiplied by 1 plus 10% multiplied by 1 minus 1 over 1 plus 10% cubed divided by 10%. Or we can use the present value of ordinary annuity we just got, 248.69 multiplied by 1 plus 10%. So we have 273.55 as the present value of this annuity due. Alternatively, again, now we're looking for the present value. We still need to press second begin, second set, second quit to change to begin mode. And then we input 3 as N, 10 as I, 100 as payment, 0 as future value. Now we want to compute for present value. Okay, we see that 3 100s in the beginning of each year is worth 273.55 for now at time 0. Okay, and again, after work on this question, you see a BGN mode. We always want to switch it back to the end mode, okay, because that's more often. In case you forget, when you start working on the next question about ordinary annuity, I would suggest you every time after you work with annuity due, you change back to end mode, the default mode, by pressing second begin, second set, second quit. Okay, nothing is on the screen for now. Okay, if you don't remember financial calculator procedures, you could always go to our notes to recall them. But in the exams, the financial calculators will not be provided. So this is something you might have to bear in mind yourself. But you don't have to worry too much because we have a lot of practice in the notes. We also have a lot of practice in the homeworks. So once you work on them for a lot of times, you should be familiar with these buttons. Okay? All right, so that's the present value and future value of ordinary annuity and annuity due. You can always use, I would recommend for those questions, you could always use the financial calculator to solve for them first, which I think it's an easier way compared to the formula way. Okay, and then if you say in the exams, you work out all the questions using our financial calculator. If you have additional extra time, you can double check your answer by using the formula to work out the questions. Okay, otherwise, I think financial calculator would be enough to solve for problems such as the present value or future value of lump sum, ordinary annuity, and annuity due. Okay, because the formulas are much complicated in these cases. So you could just work with financial calculator when you work on the questions for the first round. Okay, however, there are special questions such as perpetuity problem. It's hard to use financial calculators to solve for such problems, so you would have to use formula. And usually in these cases, formulas are easier. Okay, for example, what is the present value of 100 perpetuity at 10%? First, let's look at what is perpetuity. It is a constant stream of identical cash flows with no end. Okay, same amount of money with no end. Okay, if we receive, say, $100 at the end of each year forever, that's perpetuity. Preferred stock dividend is considered perpetuity if the company will go on indefinitely. Okay, so preferred stock promises you to give you dividends at fixed intervals, at fixed amount. Okay, so if the firm doesn't go bankruptcy, you will get a fixed amount of dividends forever. Okay, for example, what is the present value of 100 perpetuity at 10%? So here we know n is infinity. Okay, it's hard to use financial calculator because we cannot input an n of infinity. So we just use the formula for perpetuity. Present value equals the payment amount divided by interest rate. In this case, we use $100 divided by 10%. So we have $1,000. That is the present value of this 100 perpetuity at 10%. Okay, so that's perpetuity. Let's look at uneven cash flow, which is a series of cash flows where the amount varies from one period to the other. There are two types of uneven cash flows. Type 1, annuity payments plus an additional final lump sum, like bonds. Type 2, all other types, such as stock and capital investments. So type 1, we can still find the pattern here, which is annuity plus lump sum. Type 2, all any other category or patterns, or cash flows with no pattern. Okay, so for type 1, we can just we already learned how to calculate the present value and future value for lump sum and annuity. So for type 1, we just combine what we've learned. Okay, calculate the PV of lump sum and annuity and add them up. For example, if we have a 5-year 12% ordinary annuity at 100 per year plus a final payment at 1,000, what is present value of this uneven cash flow? Okay, we have ordinary annuity here, 500s at the end of 5 years. We also have a final lump sum. Okay, we're looking for present value. So we can just calculate the present value of annuity and present value of this lump sum and add them up. Okay, again, financial calculator is the most convenient way to solve for such question. So let me just input 5 as an interest rate is 12. So 12i, we're looking for PV. The payment is 100. Okay, we have 5 100s. And it's AND mode, ordinary annuity. And then this time, future value is not 0 anymore. We have to input this additional lump sum, 1,000 future value. Compute for PV. We would get 927.9 as our present value. Okay, so this time we have positive payments, positive FV. We have income, annuity income, lump sum income. We're trying to see how much we need to deposit today as PV. Okay, what if it's the same cash flow and we are looking for future value this time? Okay, if it's future value and the same in uneven cash flow, we can see on the timeline here, this additional 1,000 is already at the end of the 5th year. Okay, so we don't have to calculate the future value of the lump sum anymore. We just need to calculate future value of this 500s, future value of the annuity. And then we add the final 1,000. So we know how much they're worth in total at the end of the 5th year. Okay, so we input 5 as N, 12 as I, 100 as payments, 0 as PV, compute for FV. So we know the future value of the 500s is 635.28. Excuse me. Okay, and then we just use the amount 635.28 because we don't have sign on the timeline. Okay, plus 1,000. So we know the future value of the annuity and the lump sum is 1635.28 in total. Okay, so that's the future value of this type 1 uneven cash flow. What if we know the same uneven cash flow and we know this 5-year annuity of 100 plus 1,000 is worth 927.9 today? What is the rate of return? Okay, still type 1 uneven cash flow. We're looking for the interest rate this time. So we need to input 5 as N. Okay, we're looking for I, but this time we know the present value is 927.9. We know but we have to make this negative 927.9, meaning we're paying this much today as present value. So in the future, we can have 500s coming in at the end of each year. And we have a final lump sum, 1,000 future value to come in as well. Okay, you pay this much today, around 900. You're going to get 500s as payment, ordinary annuity at the end of each year for 5 years. And then after 5 years, you still receive an additional 1,000 as future value. Okay, and we're asking what is the rate of return here? We just compute for the interest rate, I. Okay, it's 12 on the screen. So we add back the percentage sign and the rate of return should be 12%. Okay, so that's for type 1 uneven cash flow. If we have annuity plus lump sum, we can work with payment and future value and solve for PV or I. Okay, or we can just solve for future value of this annuity and plus additional lump sum to get future value of this uneven cash flow. Okay, let's go to the second type of uneven cash flow, which is more random. Okay, there's no pattern here, there's no lump sum, or there's no annuity here. What we see is just a lot of lump sums. Okay, it can be totally random. We can receive different amounts each time at different times. The formula we are going to use is present value of this uneven cash flow equals all the cash flows from cash flow 1, 2, 3 to cash flow n. Divide by the appropriate interest rate. Okay, cash flow 1 should be divided by 1 plus interest rate to the power of 1 because we're just discounting cash flow 1 for one period to time 0. From time 1 to time 0, there's only one period. So we just discount just by ones. For cash flow 2, we need to divide by 1 plus interest rate square because we're discounting cash flow 2 from time 2 to time 0. For cash flow n, we need to divide by 1 plus I to the power of n because we're discounting it from time n to time 0. Okay? And we add all these numbers up to get the present value of the uneven cash flow. We can also stand for the same thing using this summation sign. T is from 1 to n, and cash flow T divided by 1 plus interest rate to the power of T. Okay, and this summation sign means we're using 1 to n to stand for T here and add them up, which is the same as this first item here. Okay, for example, if we have 100 at time 1, 300 at time 2 and 3, and negative 50 at time 4, we can just use the uneven cash flow function on our financial calculator, input all the cash flows and interest rates, and calculate for our present value as NPV. Okay, let me first show you the first method is to discount these 4 cash flows one by one. Okay, here, let me show you how to use our formula first and then calculator, even though I still think financial calculator would be easier than the formula, and that should be the first way to go. Okay, so using the formula, you can treat this 100 as cash flow 1, and our cash flow 2 is 300, cash flow 3 is 300, cash flow 4 is negative 50. Okay, so we can just use 100 divided by 1 plus 4%. So we have the present value of the first 100 as 96.15. And for cash flow 2, 300, we should divide by 1 plus interest rate 4% to the power of 2 squared. And then we have 277.37 as the present value of the second cash flow 300. For the third cash flow 300, we divide by 1 plus 4% cube. We have 266.7. For the fourth cash flow, negative 50, we divide by 1 plus 4% to the power of 4. Okay, and then we have negative 42.74 as the present value for the last cash flow. Okay, and our total present value would be these 4 numbers, 96, 277, 266, 42. All of these 4 numbers add up. We have 597.49 as the present value of the uneven cash flow, which consists of 4 lump sums. And we calculate the present value of lump sum 4 times for each cash flow and add them up. Okay, an alternative way is to use the cash flow register. Okay, let's use our financial calculator. We can just press cash flow CF's button. Okay, the cash flow functions include cash flow, NPV, and IRR. Okay, here we press cash flow. We see CF0, meaning cash flow at time 0. Okay, we don't have cash flow at time 0 here. Our cash flow starts at time 1. Okay, so we keep it at 0, or you can press 0, enter. Okay, on the screen you can see the enter sign, so you know we can use enter to input the numbers. And we can use up or down button to switch to next cash flow, CO1. It means cash flow at time 1. We know it's 100. Enter. Down button. We come to F01. This is frequency for the first cash flow. We know we only have 100. So we input or keep it as 1. Okay, 1, enter. Down button. We come to cash flow 2. The second cash flow is 300. Enter. Down button. Frequency of cash flow 2. We know we have 2 300s. Okay, so I press 2, enter. Down button. The third cash flow group here should be -50 now. Okay, because we already input 2 300s. So now the third group of cash flow is -50. Enter. Down button. Frequency 1. Enter. Okay, and I would also press down button to check. There's nothing as cash flow 4. Nothing. Come back until I press down button and then come back to cash flow 0. I know that these are all the cash flow I input. Okay, I input 100, 2 300, and 1 -50. Okay, this is all. So we can press NPV button to calculate the present value of this cash flow. I press NPV. I see I, so I input 4%, or I just input 4, enter as my interest rate. Down button. Okay, I see NPV here and compute instruction. I press compute. It tells me the net present value or present value 597.4794 as the present value of this uneven cash flow. Okay, I just use CF function and NPV function. Input all the cash flows in CF and input interest rate in NPV and compute for NPV. We're going to get the present value of this uneven cash flow. Okay, all the procedures are here. An alternative way to input cash flows here is that we can actually input all the frequency as 1. So for example, cash flow 100, frequency 1 as 1. But for this second cash flow 300, if you want to keep its frequency as 1, enter. Then when you go to cash flow 3, you have to input 300 again. Enter, down button. Frequency 1, down button. Cash flow 4 would be -50. Enter, down button. Frequency 4. Double check no other cash flows. Come back to cash flow 0. Okay, this is an alternative way to input those 4 cash flows. And you input 300 twice if you want frequency as 1 for each time. Otherwise, you could input frequency as 2, so you only need to input 300 once. Okay, and in this case, the NPV would be the same number. Okay, so that's uneven cash flow. What if we want the future value? We do not have a future value of uneven cash flow sign here, so the only way you can do is to calculate its present value here, like how we did. Okay, we have to go through the first step if we want the future value. And then this amount is how much the uneven cash flow is worth at time 0. Now we need to compound it to time 4, okay, after all the 4 years. So we get the future value, okay? You can either write this number down so you can input it as present value again and compound this lump sum to get its future value using the TVM worksheet, or you can press CEC here, okay? So you get out of the function, but you still have the numbers on the screen, and you press PV. Okay, so you successfully input present value as 597. Okay. And you can press 4 as N, 4 as I, 0 as payment, compute for future value. So you know this amount is worth 698 after 4 years. Okay, this is equivalent using our formula, using this 590 multiplied by 1 plus 4% to the power 4. So we have the future value here. Okay, what if we want the interest rate for the second type of cash flow? For example, if we have cash flow 0 as negative 1,000, cash flow 1 as 100, cash flow 2 as 300, we have three 300s, and then we can put cash flow 4, the fourth group of cash flow, as 500, frequency 1. We can calculate the interest rate by using IRR function. Okay, if we know how much we need to deposit today in order to get those income in the future. Okay, so let me press CF, input cash flow 0 as negative 1,000, down button, frequency, cash flow 1 as 100, down button, frequency 1, cash flow 2 as 300, frequency as 1, 2, 3, 300s, enter, down button. Cash flow 3 as 500, enter, down button, frequency 1. Okay, down button, double check. Oh, we don't have this cash flow 4 here. So let me change it to 0, enter, down button, frequency 1, down button, cash flow 5, 0, frequency 0. Okay, so all the cash flows are input. Now let me press IR and compute. There's error here. So it could be that our net present value or our cash flow it could be that I changed our cash flow 4 to 0 and I have a frequency to 1. So let me change this frequency to 0 as well. So I guess the best way for me now is to use second clear work. Okay, you can see clear work is the delete sign CEC here. So all the cash flows are, okay, not back to 0. Second clear work. Okay, so we have to press second clear work when we are in the function. Okay, when we're in the cash flow function, press second clear work. So all your cash flow inputs are wiped out. Okay, so now let's input the cash flows again. 1,000 negative as enter, as cash flow 0, down button, cash flow 1, 100, enter, down button, frequency 1 as 1, cash flow 2, 300, enter, down button, frequency 2, 3. Let me double check. Okay, we have 100, and then we have, yes, 300s, enter, down button. Cash flow 3 should be 500, enter, down button. Frequency 3 as 1, okay, down button. No cash flow 4, no frequency 4. Come back to cash flow 0, that's all we have here. Press IRR, compute. So we know the rate of return is 12.55%. Okay, so that's how we can calculate the present value of uneven cash flow by using NPV, and how we can calculate its future value by compounding this NPV as PV and compute for its FV, and how we calculate its rate of return if we know cash flow 0. Okay, so that's all for our class 1 and class 2. So far, we've learned how to calculate present value and future value of all the 4 different types of cash flows, including lump sum, ordinary annuity, annuity due, and uneven cash flow. Okay, you really need to practice on this, so you can go back to all the examples in our notes. Okay, try to work on them without looking at the formula or calculator procedures, and just try to solve for these questions by using the 2 methods on your own. And then you can go to our practice here. Okay, I have put some of the end of chapter problems. You can try to solve for these questions, and also by using formula and financial calculator procedure. You can always work with financial calculator first, as I would think the better method. And then you can check with the numbers in the bracket here to see if you did it correct. Okay, we have all the major categories of practice here: future value of lump sum, present value of lump sum, future value of ordinary annuity, present value of annuity, present value of annuity due. And that's it. Okay. You can also go to our first homework. Okay, homework 1. Again, you can see the first few questions, and you should see the question marked as the topics we discussed in the first and second classes, such as present value of annuity, things like that. So you can work on these questions now as your practice.